Yo, what's up everyone? Today we will level up our Jarvis with some cybersecurity skills. Last time we got Jarvis to do some basic task and chat with us using Mistral 7B model. Now we are diving into some real bug hunting action. So let's jump right into it. First, subdomain animation. First up, I am gonna show you how to teach a Jarvis to find the hidden subdomains. Here is how we do it. First, we need to grab the request library to make the web request. Alright, let's create our function enumerate subdomains, which will request the hacker target API to get the subdomains for a given domain. This API is super handy for this kind of task. We split the response into a list and returned it. Check this out. Here, we enumerate the subdomains sends a GET request to the hacker target API, which returns a list of subdomains for the specified domain. We then split the response by new lines, get each subdomain. Imagine we are hunting for hidden domes in a building. Each subdomain is like a new room, potentially a bulk of treasures or hidden secrets. For example, if we are looking at jumble.com, we might find blog.jumble.com or shop.jumble.com and so on. These can reveal parts of the site that are not immediately obvious. Second, directory scanning. Next up, let's talk about the directory scanning. This is like opening every door in those hidden rooms. We found to see what's inside. We are going to look for common directories that might be unprotected and accessible. Here is the plan. We create a list of common directories often have, like admin, login, uploads, images, and CSS. Then we will use request.get to check each one. If a directory exists, returns a 200 status code. It gets added to our list of found directories. Let's see it in the action. With this script, we are peeking into each possible door and checking if it opens. For instance, if we are targeting http at jumble.com, we might find http at jumble.com/admin, http at jumble.com/login, and so forth. Each discovered directory could contain valuable information or entry points for further exploration. Third, SQL Injection Test. Now, let's get a bit sneaky with SQL Injection testing. SQL Injection is like tricking a website into giving us more information than it should by manipulating its database queries. It's a classic but still a very relevant attack vector. Here is how we do it. We create a payload that can trick the site's SQL query. Our payload is a simple yet effective string to test our vulnerabilities. We construct a URL with this payload and send a request if the response indicates a successful injection. We have found a potential vulnerability. Check it out. This script sends a request with our SQL injection payload and sets the response. If the payload works, the site's database is vulnerable. Fourth one, XSS Test. Moving on, let's test for XSS, cross-site scripting vulnerabilities. This is where we see if we can sneak some scripts into a website's input fields and have them execute. Our payload for this test is a simple JavaScript alert. Script alert XSS script. We will construct a URL with this payload and send a request. If the request or response contains our payload, it means the site is vulnerable. Here is how. This script checks if the site properly sanitizes user input. If our script appears in the response, we have found an XSS vulnerability. Think of this as seeing if we can write a wall where no one is supposed to. Fifth, CSRF Test. Next up, let's tackle CSRF, cross-site request forgery testing. This ensures websites can't trick users into performing actions they didn't intend to. We will send a request to the site and check if a CSRF token is present in the response. If it's missing, the site might be vulnerable. Here the script. By ensuring a CSRF token is present, we are making sure the site is protecting itself against unauthorized actions. Imagine it like a secret handshake to verify someone's identity before allowing them to proceed. Sixth one. Open redirect test. Currently, I am on the lookout for open redirects to determine if a website can be manipulated into directing us to end the site. Open redirects can be used in a phishing attacks to trick users into visiting their malicious websites. We will create a payload with a malicious URL and construct to test for open redirects. By sending a request without following a redirects, we check if the site redirects us. Check this out. With this script, we are checking if the site can be tricked into redirecting to a URL. This is crucial to prevent phishing attacks. Think of it like making a sure a signpost can be easily swapped to point somewhere dangerous. 7th one. Header analysis. Now let's make sure the site has all its security headers in place. Security headers protect against various attacks by instructing the browser how to behave. We will send a request to the site and get the header. Then we will check for common security headers like content security policy, H content type options, H frame options, strict transport security, and XSS Protection. Here this script. This script checks for the presence of critical security headers. If any are missing, the site might be vulnerable. Imagine making sure all the locks on your doors and windows are secure. At last, I will add up these all features in our JARVIS, and that's it for today's bug hunting session with JARVIS. If you found this cool, check out my JARVIS demo video. It's a solid starter with some basic features. Also, don't miss the episode where we integrated the Mistral 7V model. Catch you next.